Hello, my dear students. Welcome to my YouTube channel, that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today's topic for the lecture is the valence and the oxidation states in the periodic table. So now let's firstly discuss what do we mean by the valence and the oxidation states. So we are talking about the valence and the oxidation states. I'm writing valence and oxidation states. What do we mean by the word the valence and the oxidation states? It is actually it is actually the number of electrons gained, lost, or shared by an element to attain nearest noble gas configuration. Nearest noble gas configuration. Now, the word valence is used for the covalent compounds. For the covalent compounds where electrons are shared between elements to attain stable noble gas configuration. We are going to discuss this topic in detail in the next lectures of chemical bonding. Now let's talk about the oxidation state. What do we mean by oxidation state? It is the number of electrons gained to form an ion, the ion with a negative charge, or lost, that is to form cation, that is an ion with a positive charge. It is the number of electron gained or lost to attain nearest noble gas configuration. So now let's take an example. I'm taking an example of oxygen. The nearest noble gas to oxygen is neon. And I'm taking one more example. Let's sodium. For sodium also, the nearest noble gas is again neon. So what's the electronic configuration of neon? It's complete 1s2, 2s2, 2p6. Now firstly talk about the oxygen. What's the atomic number of oxygen? Its atomic number is 8. Configuration will be 1s2, 2s2, 2p4. Now oxygen has to attain the stable noble gas configuration of 2p6. That means oxygen has to gain 2 more electrons to get 2p6. That is 1s2, 2s2, 2p6. Here oxygen has gained 2 electrons. I'm writing oxygen has gained 2 electrons to form anion, that is oxygen with 2 negative charge. So here oxidation state of oxygen is -2, because it has gained 2 electrons. That's why we have taken the sign of minus. Now let's talk about the sodium now. The atomic number of sodium is 11. Its configuration will be 1s2, 2s2, 2p6 and 3s1. Now sodium again wants to attain a stable noble gas configuration of only up to 2p6. So here we are having one extra electron of 3s1. So what sodium will do? Sodium will lose the 1 electron of 3s1 to get a configuration of 1s2, 2s2, 2p6. So here sodium has lost 1 electron. I am writing sodium has lost 1 electron to form cation and acquire stable noble gas configuration. So here sodium will have a charge of +1. So oxidation state is +1 because sodium has lost 1 electron. So here oxidation state will be +1. So now let's discuss in detail about all the groups and their oxidation states in the periodic table. Now let's come to the periodic table first. Here those noble gas configurations is group number 18. The group number 18 is the stable noble gas electronic configurations. Now all the elements of periodic table will try to attain stable noble gas configuration of group number 18. Now let's start from the group number 1. For group number 1, the general electronic configuration will be NS1. Here if the group number 1 lose 1 electron of NS1, they will attain the stable noble gas configuration of group number 18. We have just taken example of sodium below. So here the all members of group number 1 will lose 1 electron to attain stable noble gas configuration of group number 18. So group number 1 will have a oxidation state of +1 because they are losing 1 electron. Now let's talk to the group number 2. For group number 2, the general electronic configuration is NS2. So the group number 2 elements will lose 2 electrons to attain the stable noble gas configuration. So the charge or oxidation state will be plus 2. So now let's talk about the transition elements, that is from group number 3 to the group number 12. The general electronic configuration of transition elements, that is from group number 3 to group number 12, is n-1 d 1 to 10 ns 0 to 2. Now here the scene is that the energy of n-1 d subshell and the ns valence shell is almost equal, due to which the electrons of n-1 d subshell will also take part in oxidation states. So we are having partially filled d orbitals in transition element. So transition element will show variable oxidation states, which we are going to discuss in the chapter D and F block in the further lectures. So d subshell will show variable oxidation states, which will depend upon the number of electrons in d orbitals. They will show variable oxidation states. Now let's talk about the lengthened and actinide series. These elements will have a standard oxidation state of plus 3 only, and they will also show variable oxidation state depending upon the number of electrons in their F subshell, but their standard oxidation state is of plus 3. Now let's talk about the group number 13. The general electronic configuration of group number 13 is ns2 np1. So group number 13 element will lose total of 3 electrons to attain stable noble gas electronic configuration, and on the another hand, the elements of group number 13 are also metals, so they will obviously form cations. So the oxidation state comes out to be plus 3 for group number 13. Now let's talk about the group number 14. It's ns2 np2. So the group number 14 will lose total of 4 electrons to attain stable noble gas configuration, and it comes out to be state of plus 4. Now let's come to the group number 15. It comes out to be ns2 np3. Now from group number 15, the non-metals have started. They will show non-metallic character and will form anions. They have tendency to gain electrons. So here group number 15 elements will gain total of 3 electrons to become ns2 np6, the stable noble gas electronic configuration. So here group number 15 elements has gained 3 electrons. So the group number 15 will show the state of minus 3. Now let's talk about the group number 16. In case of group number 16, the configuration is ns2 np4. Here the group number 16 elements again are non-metals. They have tendency to gain electrons. So the group number 16 elements will gain 2 electrons to become stable, that is ns2 np6, the stable electronic configuration of group number 18. So group number 16 element has gained 2 electrons, so they form the anion with the oxidation state of minus 2. Now let's talk about the group number 17. It's ns2 np5. So group number 17 elements will gain 1 electron to attain stable noble gas electronic configuration of ns2 np6. So group number 17 elements will gain 1 electron and will form a anion with the oxidation state of minus 1. So group number 18, the group number 18 elements are already full, that is ns2 np6. They show 0 oxidation state or 0 valency. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.